Now, here is a fraction, and we can look at that and say, okay, well, first of all, if we had this as an integral, we would be wanting to know how to integrate this. We could look at this, and if our numerator had a higher degree than the denominator, and we talked about this a little bit in 8.1 or 8.2, that what I would want to do is I would want to do long division to change what this looks like. But I first check this and I say, well, that doesn't work. The next thing to check with a fraction like this is to say, can the denominator be factored? If the denominator can be factored, then we can do this whole partial fraction decomposition thing, which is what I just did with the just pure number fraction. So in this case, I look at this and I say, well, denominator here, can I factor this? Well, x times x is x squared. Okay, I need factors of 3. One of them is going to have a negative sign, one of them is going to have a positive sign, whose difference is 2. So if I say negative 3 and positive 1, x times x is x squared. My inner is negative 3x, my outer is 1x, that gives me negative 2x when I add them together. Negative 3 times 1 gives me negative 3. So that would be this thing just factored. And with the idea that I just introduced with the fraction, that means what this came from. This fraction that we started with right here was built out of getting a common denominator of two fractions that looked like this. And I wouldn't know how to integrate this fraction that I have here. However, if I can get a fraction that looks like this where a and b are just numbers, then that's going to look like a natural log. I can already kind of see that because I'll have dx over x minus 3. If I let u equal x minus 3, du would be dx, etc. That'll integrate as a natural log. So this is a way of breaking it into pieces so that I can integrate it. Now, process I have to go through here. Well, just like what I did with those other numbers, how does this come together to be here? Well, I would have had to multiply this top and bottom by x plus 1. And multiply this top and bottom by x minus 3. Again, it's not quite as simple as when I'm multiplying by 3 over 3 or 5 over 5, but x plus 1 over x plus 1 is still 1. X minus 3 over x minus 3 is still 1. And so I do that. My left-hand side is still this. And my right-hand side will be a times x plus 1 plus b times x minus 3. And then if we notice, the denominator will be x plus 1 times x minus 3, x plus 1 times x minus 3. The whole thing is x plus 1 times x minus 3. Now, as with the case where I was doing the example with a numerical fraction, the denominator is the same. If we have this equal sign right here, and the denominator is precisely the same, then that means the numerator has to be the same. So that tells me I don't even need to worry about that fraction in order to figure out what a and b are. All I have to do is worry about the numerator. And of course, in order to solve this numerator, I will have to distribute here. Once I've distributed, I look at this and I say, over here I've got 5 times x. Here I've got something times x. Here I've got something times x. Those things together, the only way I can get x's is if it's times x over here. So 5x equals ax plus bx. And quite frankly, that's the x equation. And I could write that x equation without the x's. And as far as the constant part of the equation, I have minus 3 on the left, and on the right I have a minus 3b. I now have two equations and two unknowns, and there are a variety of ways to solve two equations, two unknowns. One would be substitution. I could say, well, a is equal to 5 minus b. I could plug that in, and I would eliminate one of the variables that way. One thing I could do is I could just subtract, which is what I'm going to do, because I see that if I subtract, the a's are going to go away. 5 minus a minus 3 is 8. A minus a is nothing. And b minus a minus 3b is 4b. And that tells me b is equal to 2, just dividing by 4. And when I look at this equation right here, I say if b is equal to 2, a is equal to 3. That's all well and good. What does that actually tell us? Well, that tells us that up here, when we wanted to know, where does this 5x minus 3 over x minus 3 times x plus 1 come from? It was a, which is 3, over x minus 3, plus b, which is 2, over x plus 1. That's where this came from. Those are the two fractions that were added together in order to form this fraction.